One of the key things to understand about fractions is there are infinitely many ways that we can represent any fraction. For example, 1/3 is the same as 2/6. These are called equivalent fractions. Even though they look different, they represent exactly the same value. We can see that visually as well. Here are two copies of the same rectangle. This first one is split into thirds, so 1/3 of the rectangle looks like that. This copy is split into sixths, and 2/6 of the rectangle look like that. Clearly, 1/3 and 2/6 are the same. They are equivalent fractions. And this is what they look like on the number line. Here's 1/3, here's 2/6. They're just different ways of representing the exact same quantity. Let's talk a little bit more about the definition and how to find equivalent fractions. So here's a bit more about what equivalent fractions are and how to create them. To write equivalent fractions, all we need to do is multiply or divide the numerator and the denominator by the same non-zero number. For example, to get from 1/3 to 2/6, all you need to do is multiply the numerator and the denominator by 2. That gets us to this equivalent fraction. We could do that again. We could multiply the numerator and denominator by 2 or by something different like 4, for example, and we would get another equivalent fraction. In this case, we would get 8/24. So to get an equivalent fraction, we just multiply the top and bottom by the same thing or divide the top and bottom by the same thing. You can see that written out with letters here. Notice that b is not allowed to equal 0 because we can't have 0 in the denominator, and c is not allowed to equal 0 for pretty much the same reason. If we multiply the top and bottom by c, well, c can't be 0, otherwise that would force the denominator to be 0. On the other hand, if we divide the numerator and denominator by c, again, c can't be 0 because we can't be dividing by 0. And then here are a few more examples with numbers. Let's go ahead then and write two fractions that are equivalent to 4/10. For one example of an equivalent fraction, we could multiply the numerator and denominator by something. Maybe we multiply the top and bottom by 3. That gets us to the equivalent fraction 12/30. For a second example, perhaps we divide the numerator and denominator by 2. They both have a factor of 2 after all, so this would actually simplify the fraction. We'll divide the numerator by 2 and the denominator by 2, and that gets us to this equivalent fraction 2/5. So all of these fractions, 4/10, 12/30, and 2/5, are numerically the same. They represent the same value. On a number line, they'd all be one single point. This idea of equivalent fractions has a lot of uses. When we're trying to get a final answer to a problem, a lot of times we'll divide the numerator and denominator by a common factor if we can to simplify the fraction. Other times we will multiply the numerator and denominator by something to change the fraction's denominator so that it matches the denominator of some other fraction. Let's finish with a few basic example problems. Here are 4 examples of equivalent fractions. We need to figure out what the missing numerator or denominator is. In this first example, 1/2 is equal to what over 8? Well, for these fractions to be equivalent, we see that the 2 must have got multiplied by 4, so the 1 must also get multiplied by 4. So the missing numerator we're looking for is 4. In this second example, 4/11 equals 12 over what? Well, we see the 4 must have been multiplied by 3 to get to 12, so the 11 must be multiplied by 3 to get the desired denominator of 33, and these are equivalent fractions. In this example, 3/21 equals what over 7? Well, 21 must have been divided by 3 to get 7. So 3 must get divided by 3 to get the missing numerator of 1. In this last example, 10 must have got divided by 5 to get get 2, and so 30 must get divided by 5 to get the missing denominator of 6. And that's how you solve these basic equivalent fraction problems. Let me know in the comments if you have any questions, and check out my pre-algebra course and pre-algebra exercises playlists in the description for more. Thanks for watching.
Couldn't even open myself up for an instant. What's the law? It's regular. I regulate my integrity. I'm a secular anesthetic for my own effigy. I didn't try just to be regular.